All right, for this lesson, Unit 10-3, we're going to be doing more factoring. So we're going to be doing some more factoring, but these are what we call special cases. Now, for our warm-up here, we're going to actually do a few problems that we did before the break, before Christmas, and we'll show you why we call them special cases. So remember from our previous lessons too, we did this in yesterday's lesson and again before the break, but when you multiply two terms of a polynomial with two terms here, you've got to do 4 multiplications. So we're going to actually multiply the x to the x to the -4, then we've got to distribute this 4 to two terms, 4 to the x and 4 to -4. So let's go ahead and start on those 4 multiplications. So x times x right here gives us an x squared. When we distribute our x to the -4, we've got a -4x. Okay, halfway done, we're now going to distribute our second term. We're going to distribute this 4. 4 times x gives us a positive 4x, and 4 times -4 will give us a -16. Now, this is what we call a special case because normally when we do that 4 multiplications, normally we're going to have 3 terms. We can combine our middle terms here. But notice right here, if you add -4x to positive 4x, they just disappear. We have 0x. We don't have any x's left. So what happens is we're missing that term. It just turns into a binomial. We just have our first term, our x squared, and our last term, our -16. So we've got just a binomial instead of a trinomial. So that's what we call a special case. Let's look at this last example here on the warm-up. So we're going to do the same thing, 4 multiplications. 5m times 5m is going to give us, 5 times 5 is 25. M times m is m squared. So we've got our 25m squared. 5m times -1 gives me a -5m. Now distribute your 1 to both terms. 1 times 5m gives you a positive 5m. And then 1 times -1 gives you a -1. Again, this nice lovely problem has these middle terms that just cancel each other out. -5, if you add 5 to -5, you have 0m, which we don't need to write down when it's 0. So we just have 2 terms here as well, a 25m squared and a subtract 1. All right, we're going to do this next thing and then we'll do the examples in the next problem. So we're going to see some patterns here. Notice as well, when we're factoring these, what we mean by factoring is we mean that this that was the answer for this time is now going to be the problem, and we're going to ask you to turn it back into what was the problem. Same thing here. We're going to ask you to factor this 25m squared minus 1 into the 2 binomials right here. So when you have a binomial, you can only factor it if 3 things happen. So you have to have what we call a difference of squares. So difference means that you've got a subtract sign in the middle. So just make sure that they've got a subtract sign in the middle. And then you've got to make sure that your first term and your last term are both what we call perfect squares. Now, it's easy if they tell you it's a square. This x tells me that it's a square, so that is a square. The 16, it's a little trickier. You have to look for numbers that might be squared that give you 16. In this case, notice our 4. If we square 4, 4 squared, or 4 times 4 gives us 16. So that is also a square. Okay, same thing here. You've got to have a difference, and then you've got to make sure that this is a square. Now, is 25 a square? That means, is there a number multiplied to itself that gives you 25? Yes, 5 times 5 will give you the 25. Again, they're easy with the letters because they tell you that they're a square. They tell you that they're m times m. And then 1 is also a square. It is just 1 times 1. So if those 3 things happen, if you have a difference and 2 squares, then this is the rule that you're going to work. If you've got a square, subtract a square, it always factors into 2 binomials, kind of like up here. Again, we're trying to turn it back into this. Notice the signs. There's always going to be 1 positive and 1 negative. It doesn't matter the order, but there will be 1 positive, 1 negative. So we're going to put a positive in the middle of 1 and a negative in the middle of 1. And then you just take the square root. So the square root of 25 was 5. The square root of m squared is m. So right here, the square root of a squared, well, it's easy. It tells us what's squared. So the square root is just a. Again, you do the same thing with your last term. The square root of b squared is b. So it's going to go right there. And that is the rule. So we're just going to use this as our rule every single time. You're just going to substitute different A's and B's in and get it like that. All right, before we go on to the next video though, we're going to talk about perfect squares because this is usually the hardest thing for people. They don't know if these numbers that they're looking at are squares or not. So we're going to write down as many squares as we can right here to remind ourselves. Perfect squares are numbers that are multiplied to each other, like 1 times 1. So 1 times 1 is 1. That is what we call a perfect square. 2 times 2 is 4. That's a perfect square. 3 times 3, 9. And we just kind of keep writing them. 4 times 4, 5 times 5, 6 times 6 is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And let's stop here with 15 squared is 225. So these numbers are all what we call perfect squares. If you see them in your binomial, you know that you can take the square root. So we're just going to get really familiar with those, and we'll do our examples in the next video.